In a lab filled with PhD students
We're trying to mimic what's happening in the brain.
and neuroscientists,
That's what spreads the disease.
research is underway that could have a profound impact on Parkinson's patients when it comes to diagnosis and treatment.
That'll be a big challenge when it comes to biopsies.
So that's what these students are reproducing that in the lab.
An internationally renowned Parkinson's researcher, Anumanta Kantasamy, was recruited to the University of Georgia in 2021
So that's kind of intrigued me.
to establish and lead the Isaacson Center for Neurological Disease Research, named for the late Georgia Senator Johnny Isaacson, who was diagnosed in 2015.
The L-DOPA is a gold standard treatment. It was discovered 1960s.
In Parkinson's, the brain slowly loses dopamine-producing cells. Dopamine is what helps control smooth, coordinated movement. Its loss leads to symptoms like tremors, stiffness, and slow movement. The medication levodopa, also known as L-DOPA, replaces dopamine lost in Parkinson's disease. It is taken multiple times a day and usually works well for several years.
The challenge with the drug is what we call is the half-life is very short.
So it's short-acting.
Yeah, short-acting, and the decay is fast. The dose goes away quickly within 3 to 4 hours.
Kantasamy and his team tackled a very real issue in the Parkinson's community.
And then they just go for grinding.
What happens after several years when L-DOPA is not as effective?
Every time you take a dose, plasma level, brain level goes up, comes down. Then again, take another one, goes down, comes down. The brain wants everything in homeostasis.
Parkinson's disease continues to damage dopamine-producing cells in the brain, so that years into the disease, there are fewer cells to convert levodopa into dopamine and store it for release. In addition, the effects of levodopa aren't lasting as long, requiring more frequent doses. Off times happen when symptoms return before the next dose kicks in. There can be increases in involuntary movements called dyskinesia and freezing episodes.
Our goal is to make an engineered live biotherapeutic product that's essentially like a microbiome, like a bacteria, a probiotic, that has been engineered to produce a drug molecule.
Kantasamy and his team have created a levodopa-producing probiotic
And in this plate, we have streaked bacteria onto it.
that would be taken once a day and would provide a steady release of L-DOPA. Using E. coli Nissl, a beneficial bacterial strain known for its probiotic properties and often used in supplements and treatments for gut health, the team created the L-DOPA producing probiotic.
And put a gene that makes the L-DOPA. So we insert it into the bacteria's gene, then won't recognize them as a foreign gene.
And from one single colony, we're able to get a nice, dense culture because the cells multiply, they replicate. This bioreactor, essentially, it makes cells. We can grow up to 10 liters at a time, and we let it grow, let it ferment inside of it for up to 12 hours.
Tucked inside the probiotic, once digested, L-DOPA is released from the gut for 24 hours at a continuous, steady rate.
But our surprise, it worked really well, better than we thought.
This test is called the balanced beam test.
Right now, the research is in animal models, and the results are stunning.
This is constantly producing L-DOPA, but when we give it to the mice, these cells will continuously produce the L-DOPA, so the animals get this sort of anti-Parkinsonian benefit, and they are essentially back to almost like close to being as normal as possible.
Here is a mouse with severe Parkinson's symptoms.
They have like slight gait issues, they're walking slower, they don't know what to do, and that is all part of the dopamine process. This is a healthy mouse.
And here's a mouse who has received the probiotic. The researchers precisely measure every step.
So you can see that the animals, as they're walking across, it's picking up each of the paw prints, which we have classified. And we can obviously control the speed here so the animals can walk at a normal pace. And you can see his paw prints.
So when could this probiotic be used by Parkinson's patients?
I think we would like to see at least next 5 years.
One of the other areas of research for Kantasamy's team, They are creating a skin test for Parkinson's disease.
Basic idea of the assay is to be able to differentiate between Parkinson's disease and control.
Right now, neurologists diagnose it by doing a clinical exam and sometimes brain imaging. A skin test would be a game changer.
So we take a small punch. It's kind of when you go to dermatologist, normally take a small punch. It's a 3 millimeter punch, a biopsy. So you take that and we can test them in our lab and then identify that protein using some seeding activity assay that's we developed.
Emory University is part of the Michael J. Fox Foundation's Parkinson's Progression Markers Initiative, a biomarker study that began in 2010. In 2023, the Fox Foundation announced a huge breakthrough, that a protein called alpha-synuclein could be identified by examining spinal fluid in patients. In people with Parkinson's, this protein can misfold and clump together abnormally in the brain, where it can accumulate not only in spinal fluid, but it can also build up in skin cells.
That accelerates the protein aggregation that happens in the misfolded alpha-synuclein.
Skin tests done by Kantasami's team from Autopsy showed 93% accuracy in predicting if that person had had Parkinson's disease. Skin tests in living patients have a slightly lower accuracy rate.
Currently about 80% accuracy, so we want to get up to 90%.
So that's what the reader.
By looking for abnormal alpha-synuclein protein in skin cells, these tests offer a simple, non-invasive way to detect Parkinson's early, even before symptoms appear. Kantasami hopes it's in wide use within 5 years.
Sometimes it's out of the box idea that works. That's what makes a great science and discovery. And that's why this job is so exciting. It's stressful, but at the same time in a good way, good stress.
Kantasami and his team are collaborating with Emory on this research, including the creation of a probiotic for people with Alzheimer's disease. Instead of bacteria producing L-DOPA, bacteria would be producing norepinephrine, a neurotransmitter whose levels drop in Alzheimer's disease. When norepinephrine goes down, amyloid levels go up. The hope is that boosting norepinephrine could decrease amyloid levels.
I grew up in an agricultural family. So I work with a lot of chemicals and pesticides and just kind of passionate about, how chemical affects human life.
From the time he learned how pesticides and chemicals could increase the risk of developing Parkinson's disease, this has been Kantasami's passion. First, as a neurotoxicologist, understanding how external environmental chemicals affect the brain, and now as a Parkinson's researcher, figuring out what he can do about it.
Some people think that, it's an idea is not going to work. We ask that question, unless you test it, how do you know?